Thank you. Thank you for attending, and thank you for joining this session. We are going to talk about the Kusto experience in Fabric. And once I submitted this session, the name was still Kusto, but a few weeks back, Microsoft changed it to real-time analytics in Fabric. So don't be mistaken, we are still talking Kusto, but the real official name is now real-time analytics at scale in Fabric. It is still the same content, it is still the same session, and I hope you are in the right place here in Teams, in the right room, and I appreciate you all being here. A short thing about me. My name is Brian. I'm the principal architect of data and AI at Fellowmind, a European organization. I'm a data platform MVP and also a fast-track recognized solution architect since 2022 and a Microsoft certified trainer. If you want to link up, you have the link to LinkedIn right here. And I also have, I do a bit of blogging. It has been quiet for a few weeks now, but I'll get back there. And if you would like the slides and the code that I will show you during this session and the demo, you can find it on my GitHub account right here. I will also share these links later on once we are done with the content. Speaking of Kusto, the name Kusto is still around in the area of real-time analytics, and it is the name of the database that we use when we want to handle all of this data. A small introduction to where the Kusto name comes from. It actually derives from Jacques Cousteau, who lived his entire life under the sea to explore the world under the sea for what was to find there until his death in 1997. The last name Cousteau is actually the Kusto. They are inspired by his last name to call it Kusto, because Kusto is exploring the ocean of data instead of exploring just the ocean. So that is perhaps a fun thing to know, that Kusto is actually derived from Jacques Cousteau. And in the era of AI, I would also try to get AI to recolor this in color, and I think it did a rather good job. Well, back to the content. Whatever we do today, we are generating a lot of data. We are generating data in petabytes and zettabyte scale. And data is all around us, even though we don't want it. It is on our mobile phone, it is on our watch, on our car, on whatever we do, we have data around it. Some of this data is sensor data or telemetry, and telemetry will be a key in digital transformation going forward. Telemetry is an umbrella of words and processes and method. I have brought some of them here: logging, time series, IoT devices, events, security, and so forth. Perhaps you know some of these words. If you are working with data and are talking about some of these words here, you might be a possible candidate for using the Kusto experience in Fabric or real-time analytics in Fabric. Just to set this insight in perspective, Microsoft has tried to guess what the amount of devices we have online during the year of 2025. Microsoft hopes that it is 75 billion connected devices by 2025. And connected devices is devices streaming some sort of events, telemetry, logging, security events, or something. It is not just a laptop. It could also be a thermometer or a mobile phone or a webcam or something. Some devices streaming data out into the big internet. All of these devices will potentially stream around 19 zettabytes of data a year when we reach 2025. This is huge amounts of data, and we need a software or a service to handle all of this. And this is where real-time analytics in Fabric comes to play. Digital transformation is all around us. Data is changing all strategies all around every organization, and some of these words are also possible candidates for using the Fabric experience. Sorry, the Kusto experience in Fabric or real-time analytics. If you work in energy management or in supply chain or fleet management, you are a very, very possible candidate for using this kind of service. Don't get mistaken, it is not a service to build your data warehouse on, because you cannot do updates, you cannot do deletes, so you cannot build dimensions and facts and what you would in a normal fact and dimension kind of world with history on it, perhaps slowly changing type 2, 3, 5, whatever. That is not the usage of this service. It is a service meant for fast ingestion and compute when you need it. I'll get back to that later. This slide has been shown a lot in the past 4 or 5 months after Fabric was released in public preview. And this session is focusing on the real-time analytics. And the real-time analytics umbrella is also covering Data Activator. And if we have time during this session, I will briefly show you what Data Activator is and what the capabilities are there. I hope I can reach it, or else I'll do another session later on this year. Microsoft has their own definition of what real-time analytics is. I brought it here. What I would like to focus on, I just need to find my laser pointer, is it is built for data in motion, and it is built to democratize data. So data in motion is meant as whatever data you have that are coming in. If you would like to store it in the real-time analytics part of Fabric, it will absorb it. It will guarantee that it is stored there, and it will also perform blazingly fast once it is stored there and you need it out to either Power BI or another application to be used for analytics later on. Democratized data, this is a part of Fabric, so you can share it as you would any other data set inside Fabric, and even though it is a streaming data set, you will be able to share it from one lake. I'll get back to that in a minute. Inside real-time analytics, we have different services. One of them is EventStream. EventStream is the service built on Event Hub and EventStream, which can help you ingest data from your IT devices or streaming devices. On your left side, you can define sources and map them to the EventStream. In the center part of this picture here is the EventStream engine, and in here you can do simple filtering, simple grouping, simple calculations if you would like, but you actually don't need it because the KQL database on your right side here will handle it for you. I'll show you that later. You can also, of course, pipe it to your lakehouse if you would like it, and then you are good to go with your data once this is online. I'll show you this in a minute on how to do it. The Data Activator is also now in public preview. Around the Fabric universe, you might see it as Reflex because the name is not yet changed all over the place, but the official name is Data Activator. It is meant as a active listener to your data. It listens to your event stream data that comes in. If it goes beyond or below a certain threshold that you define, it can do some actions. It can either send you a Teams message, it can send you an email from Outlook. Right now we can't show you the Power Automate because that is not yet enabled. I hope that will be very soon. And then we have custom action, which is actually just an API call, a post call that can do stuff for you. The sky's the limit here, so whatever event is happening beyond any threshold or below, things can happen for you. You could get an alert, you could set up a service call if your car is broken, so forth, so forth. The sky's the limit here. Wow, this is twice. Okay, sorry for that. The other big offer inside the real-time analytics is the KQL database, and it has some key capabilities. I'll not go into deep of all of these 9 because then I'll talk for a few hours. It is capable of handling both structured, semi-structured, and free text data. So whatever data format you have, JSON, HTML, CSV, column and rows, it can handle it. Just put it towards the service and it will be stored there. You don't need to do transformation before you need it. It is at query time you do your transformation and the queries will perform if you write it correctly. It is handling near real-time data, and this is not to go into the philosophical part of this, but once an event has happened, time has also gone by, so it is not real-time, it is only near real-time. If you have worked with any time series database from other vendors, this is the go-to service for Microsoft. It is a time series database, and with that, everything is indexed. Also, your dates and times, date times, and all your other columns in the table or the object. It is built for high performance and high freshness. So once the data is stored in the database, it is actively live to the Power BI reports or the application that you're using. This is a possible example of a architecture integrating real-time analytics in its core. We have sources to the left, lakehouse, warehouse, structured, unstructured, event stream, and there is now also a possibility to connect a machine learning model to your Kusto database, to the real-time analytics in Fabric. So once the data is streaming into your Kusto database, it is actively scored against the machine learning model, and the result is stored directly in the Kusto database at time of event. This is hugely usable because you don't have to do manual API calls to your machine learning model. The Kusto database does this for you once the data comes in. And Microsoft loves to tell you the story that OneLake is the one place where every data in Fabric will be stored. That is unfortunately not true, because the Kusto database is still using the Microsoft proprietary database called Kusto, and it is storing data there. This is because the Kusto database is built for fast ingestion, fast load, and fast query time. As you would also see, Microsoft is using this database in their own services for log analytics, for Sentinel, and for other logging services inside the Azure and Microsoft Office world. They are using this service, and a few years ago they figured out, oh, we can actually sell this as a commercial product, and there you go, we have the Kusto database. If you need the data in your OneLake, you have to enable the mirror, and then the objects will start to mirror out into your OneLake as Parquet files, and then you can begin querying the data from there. One thing to notice is that you are built on the storage, and if you are beginning to mirror your data, you are not built for the mirrored data, you are only built for the storage inside the Kusto database. It is compressing data in a factor between 6 and 10. I'll show you that later. So if you load in 10 gigabytes of data, it might only store as 6 gigabytes of data if you're lucky. You can use the data in Power BI in a Kusto query set. A Kusto query set is just, if you are a SQL man, a SQL person, sorry, just see it as a select statement, and you can also use it in your Jupyter notebooks as a source. There's a free option. You can get started for free if you are interested. dataexplorer.azure.com/free cluster. Then you get a cluster with a capacity of 2 gigabytes. And as I just told you, it is compressing data between 6 and 10 as a factor. So you have a maximum possibility to load in around 10 gigabytes of data there. And that is enough to get you rolling and to learn what is this all about. If you are completely new to the Kusto experience and how to write the KQL, the Kusto query language, the select statements, and all the manipulation statements that you're using inside this database, it is a completely new language. It is not that hard to learn, but it is still, you need some knowledge on how to use it. Microsoft has built the Kusto Detective Agency, perhaps the best gamification I have seen to learn a coding language, detective.kusto.io. You get it for free. It is a free game. It is quite fun. They just ended season 2. If you would like to start, please start at season 1, because there is a story. There's a storyline going from season 1, case 1 to season 2, case 10. There's 10 cases in each season, 20 cases in total, and you play the detective on trying to analyze your way into finding car stealers, robbers, banking fraud, and all these kind of stuff. It is quite amusing, and if you are completely new to it, expect to use around 2 or 3, perhaps even 4 hours on each case. It is quite fun, and there is a lot of help to find on the big internet. Of course, no data is usable without a form of visualization or analytics tool, and here is Power BI comes to play. And I need to tell you something now, and just please just take it as it is, and trust me, it will work. So forget everything you know about query performance versus data types and data modeling best practices when working with real-time analytics in Fabric or in Azure Data Explorer. Why is this? Well, it is a proprietary database built by Microsoft for log analytics, for analytics based on logging, telemetry, IoT devices, and so forth. You heard about this a few minutes ago. And the database is optimized for broad tables with select statements on them, with filters on them, and with groupings, calculations, all this stuff. It is built for extremely broad tables. And it is also built for indexing every column you have. So you don't have to think about, oh, I need to store this as an int because then it takes up less space than a string. But don't worry about it. Actually, a string column will be way more performant than an integer. I'll get back to that later. This gives us some options that we need to take care of once we use the Power BI service for the Kusto. Single table reporting is a good option if you can include all columns from a dimension to the table. I just talked about that. If you have an extremely broad table, that is completely fine. Just keep it as it is. You don't have to do data manipulation or data modeling on top of that. Keep it as it is. It will perform once you put it inside Power BI. If you really need to do facts and dimensions and to build relationships in Power BI, you will see that Power BI defaults back to the many-to-many relationships because those are hard to avoid. We are using the direct query option in Power BI. So Power BI is not reading the entire dataset. It only reads a subset of it. And from this, it cannot determine which side of the join is the unique one. So it will default back to many-to-many. It is quite fine. Don't worry about it because everything you do in Power BI will be query folded back to the engine in the KQL, the Kusto query language format, and the engine will deliver the data back to Power BI. This also gives that if you're using DAX measures in Power BI, those will also query fold back to the KQL language, even though even in a broader scale than if you were to use DAX towards a SQL Server in direct query, because that the real-time analytics team inside Microsoft is actually building their own connector in Power BI to translate from Power Query and DAX back to the KQL language compared to the SQL connector, which is built from Power BI and not a SQL Server team. So they are doing the best to translate DAX to SQL. So we have a completely different connector here that performs out of the box blazingly fast because it is built from the people who also built the database. If you have dimensions, it is a good option to tag them as is dimension equal true. I'll show you this in the demo because the Kusto query language is normally in SQL, you will have your fact table, and then you join your dimension table, and then you do your where clauses, then perhaps you do some calculations and some group bys. In KQL, it's the other way around. You begin with your dimensions, you get your filter set, you filter your dimensions, you join them if you can, and then after that, you join in your fact tables because then you are building your query as a funnel, so extremely broad data, and then you filter it down more and more, and you end up with a result set. So the KQL language is perhaps upside down, if you like, in means of facts and dimensions. If you have dimensions that are less than 1 million rows, it can be more performant to import them, but don't worry about it. If you don't want to import it, it is quite fine just to have it as direct query. You can also build a composite model, so you have some tables that are imported from a SQL Server, and then you have your entire fact table as a direct query mode in Kusto. It will also query fold back to the database. A small thing to remember is that integer and decimals are slow joins. If you do joins there, it is far more performant to do joins on strings. So A bit of mind-blowing things here, but if you take these things into account working in Power BI, you will get a good performant data model and report. If you are as old as me, you know this guy, He-Man. He has the power of Grayskull, but we would like to have the power of Kusto in Power BI. And so Power BI can actually queryfold everything not everything, but a lot of the things that you're doing in Power BI back to the KQL language, either in Power Query or by using DAX. I just told you about that. There's another option, building a Kusto function. A Kusto function is just the equivalent of a SQL store procedure. It accepts parameters and it outputs a data set. So enough slide decks. Let us dive right into the bits and bytes here. Let me jump into Fabric. This is a workspace. I already made it. Sorry, I'll just go back to the workspace here. This is a workspace. I cheated a bit because I need a lot of data in order to convince you that this is quite performant. I've created a KQL database. When we saw this in the first period of the preview, it took around 5 to 10 minutes to provision this. Now the team has done a lot work behind the scenes to optimize this. So now we see this in around 1 to 2 minutes. But still, to save time, I already done it. I've also created 2 event streams. One event stream is streaming from the New York City taxi. It is on the left side here. This is the source, and then I can do some manipulation in the middle, and it is storing in the New York City taxi destination in my Kusto database. You can see a rather fast snapshot of what has just been ingested this second, actually, and then I can see an example of the data that I'm getting. If I would like, I could also hit data insights to see what kind of roast am I getting, what are the incoming messages during the past hour. I can change this window to see what has been ingested in the last week, on the last 2 weeks, and so forth, so forth. I've also created an empty event hub because this takes a few minutes to create and to show you how easy it actually is to start ingesting data from an IoT device or a streaming event. In the source part of it, there's a sample data. Here I can select the New York City taxi or the stock exchange. There's event hubs, IoT hubs, and then a custom app. A custom app is just providing you with a 2 secrets and a connection string, and then you can put that into a Python app or whatever app you have to begin sending data into this event hub. Sorry, event stream. I'll choose the sample data, and the source name is just New York City taxi data weekender. And the sample data here is yellow taxi. I could also select the stock market, but I'll just go with the yellow taxi. Then it's adding the sources. In the event hub, I can see the data format. Once it starts streaming, it will just take a second or a minute, and there you go. This is the first data set I just received from the New York City taxi. It is not live or real time, so the date is not as in now. It is just an example data set. If I would like to store this in my Fabric universe, I can store it in the Lakehouse out of the box. I can store it in a KQL database out of the box, and I can send it to. This is actually data activator. I just told you that you might see Reflex somewhere. This is one of the options. This is data activator to send it to data activator and then have data activator do stuff once it hits certain thresholds. I'll select the KQL database, and the destination here is KQL data weekender. The workspace is, I need to find data weekender, it's there, and the database is, I just named my KQL database, so I can find it, and also for demo purposes. Now it's adding the destination, and it shows me a new pop-up where I need to select where do I need to store this, in an existing table or a new table. Let me just store it in a new table, New York City taxi new data. Once I hit this, it shows me how would you like to configure your data source. The data connection name needs to be unique, and I've already created one that has this name, so I'll just call this data weekender. So it is unique, and there are different options in the advanced filters where I can hit compression or event system properties. And if I need to filter the data on a specific start date, I can choose it here in backend time. Once I hit next, it will start to read the metadata from the dataset that it is getting. It is not adopting the source destination, the source data structure, because you just saw that it was JSON. So here I need to explicitly select the JSON format, and then you will see the data structure is now showing that I have the columns, the vendor ID, the pickup time, and so forth, and with example data done. Once I've configured this, I hit finish, and the data connection is created, and it will start streaming data into my KQL database. Don't worry, it will show a warning at the beginning, and then within a few seconds, it will start to ingest data. This was rather fast. A few days ago, I could experience perhaps 5 or 10 minutes wait time where it just showed a red box showing warning, but now it is showing ingestion. So now I have set up my streaming, my source, and I have set up my destination as the KQL database, and I'm actually now ready to build my data model. Back to the KQL database. Here you can see this is the, I can't spell, sorry, there's a typing error there, so sorry for that. This is the table that is now accepting rows. It has not yet gotten any rows. It will happen. Rows will come in within a few minutes. But I've created this some time ago, and it is actively ingesting data from the New York City taxi that I just showed you. It has a row count of approximately 1.1 billion rows, and within the last 24 hours, I have gotten around 3 million rows. I also told you that it is compressing data. The original size of these 1.1 billion rows is roughly 200 gigabytes. But once it hits the KQL database, it is compressed to only fill around 30 gigabytes with a compression ratio of around 6.6. You might see different compression ratios once you use your data for this, because the compression is based on the compression ratio is dependent on what kind of data structure you have, how broad it is, how long it is, what the data types are, and so forth. The KQL database is not by default streaming data to the OneLake folder. So there's an option here. I've enabled that, but there's an option here to stream data to OneLake. If I hit the pencil here, it is default disabled. So I've actively enabled this, and then it gives me a folder to where do you want this data stored. And once it is enabled on the database, I can begin to enable it on tables, and here it is already active. And again, I choose a folder, and then data will begin to mirror out to my OneLake. If I don't do this, you will not find the data in the OneLake folder. It will only be stored in the KQL database for you. Before I can begin to query anything, I need to copy the query URI. I find that on the top level here. I have the KQL database, and in the top level in the database details, I find the query URI. I need to copy this, and then I can go into Power BI. Power BI has a standard connector for connecting to Kusto and real-time analytics in Fabric. It has still the old name of Kusto, so you need to find it here, Azure Data Explorer, in parentheses Kusto. This is the connector you need to use to connect to your data in your real-time analytics database in Fabric. Connect. And then it asks for a cluster name. I'll just paste it here because I just copied it from Fabric. And now I need to make sure that I select the direct query mode in the data connectivity mode. It is not default shown once I start to configure the connector. So I need to scroll all the way down and find it and hit direct query mode. I hit OK. And then I am presented with Just hang on, it reads it. Then I'm presented with the structure of my KQL cluster or database in Fabric. I would like to get the New York City taxi table. I select it here as I would any other Power Query mode. And then I get an example data set so I can validate, is this what you would like? Yes, it is. I hit transform. And now I'm getting the usual Power Query experience I would any other data set. And this is now helping me to write KQL. If I don't know how to write it, I can get help from Power Query if I'm rather okay manipulating or changing my data in Power Query. If I could add a column, a custom column, to get perhaps the year of the pickup time. Year of pickup time. The column here is date.year. Yes, and then IntelliSense is killing me. There you go. And then pickup time. There. Rather simple Power Query function here to get the year of a column. Then I hit OK. Then I'm, as expected, getting the year of the pickup date, and I've added a new step here. Now I'm in direct query mode, so I have a new menu item in my right click called View Native Query. It is right there, View Native Query. If I hit this, let me do it again. I'm now presented with the query in KQL language. So whatever I'm doing in Power Query is now translated into a KQL query. So if you are okay by manipulating your data in Power Query and you would like to learn KQL dataset, then please do it in Power Query. Right-click the last step, and then you can see what is actually happening in my Power Query as I'm going through all the steps. Eventually, you will hit functions that are not query foldable back to the KQL language. You'll see that because then the option of I'll just go back. Sorry, I lost it there. The option of view native query is disabled. It is grayed out, so I cannot hit it or click it. And you will get an alert box at the top of your window saying you have used functions that is not foldable back to the KQL language. Please choose another option or something like that. Then you have to go back, delete the step if you would not have early materialization, because if you are continuing from that place, Power BI will begin to import data before it does all the calculations for you, and you are not interested in having 1.1 billion rows inside Power BI. Enough of this. Let me just close and apply. Now Power BI goes in and reads all the metadata from my table, the New York City taxi, and within a few seconds, I am ready to build my report. If I would like to get the airport fee, perhaps, I don't know. Let me just start with the airport fee. And remember here, I'm actually live reading 1.1 billion rows from the database, and it shows me the result set within an acceptable amount of time. I can also add a filter for the year of the pickup time. Just load. There you go. And if I select perhaps 2013, Power BI does the direct query mode and selects the data from the 1.1 billion rows in Kusto and returns the data to me within a second. I'm not actually handling 1.1 billion rows in Power BI. I'm query folding whatever I'm doing back to the Kusto engine, and then the Kusto engine does all the compute for me. And I'm returned in this example here. I'm returned with one table, one column, and one row. The column is airport fee, and the row is 251 million in, I think it's dollars. Let's just say dollars. Imagine this was any other IoT device that has a lot of data, perhaps an energy meter or something. Then you can now begin to see the live data in your reports directly from Kusto without having to import anything. The Kusto engine will perform for you. If you really need to have these data models, let me show you how to do that in the dimension. Again, I'll select the Kusto. And now I won't connect to my own Kusto cluster because I don't have a star schema there. I only have one table. But Microsoft is providing us with a cluster, a read-only cluster, where I can get different types of data. If I type in help in the cluster name here, just type help, no other things, and select the directory mode, hit OK. And then within a few seconds, you will see that I have different options here. I have the controls for sales, I have sample logs, samples, trender, and so forth. If you are as old as I am, you know the controls for sales data model is a rather okay star schema. So let me unfold this and select customers, products, and the sales facts, just for this demo purposes, and transform the data. From the slides, perhaps you remember it, you saw that I need to tag my dimensions as is dimension equal true. This to help Power BI know the sequence in which I need to select my tables. So the customers, and in this example, I'm choosing the customers table. In the source step, I'm getting this. Can I get it to fit? No, I can't. There. This is the connector. This is the cluster. This is the database if I chose any. This is the table if I chose any. Now I have none, so I'm just browsing my way through the objects, and these are the properties for the connection. These properties should now be added with is dimension equal true. So after the last null, comma, is dimension equals true. Let me just copy this because I need to do it again. There you go. Now I'm helping Power BI understand that this is the dimension table. So please put it on top of the query set once I'm doing it. And the products, again, the source, the last null, and enter. There you go. So now I have told Power BI the customers and the products tables are dimensions, and the fact tables is just a table. That's fine. Close and apply. Now I'm getting a security risk because I have two different data sources in the same data model. That's quite okay for demo purposes. And just build the data model. I have still my three tables, and you can see the difference in colors. This is my from one source, it is lightly blue, and this is from the other source, it is more dark blue. Let me join the customer key to the customer key to show you that it defaults back to many-to-many. In the first couple of seconds, it will say, okay, many-to-one, it's fine, but then it will default back to this relationship has cardinality many-to-many because it is only reading a subset of the data, not the entire data set, so it cannot determine on which side of the join the unique rows are. So it will just default back to many-to-many. It's fine because everything I'm doing is folded back to Kusto query to the Kusto query language, and then the engine will do the join for me. Again, I'll do the same with the product key to product key. Okay. And did I make a mistake here? Because no, I did not. Okay. So now I have my data model extremely simple, and now I'm ready to build my visualizations. And if I would like to see the total cost by, I don't know, last name, this is perhaps not a usable report, but still just so you can see, I'm getting the results back quite fast and quite effective here. And this is still direct query mode. And if I'm adding, I don't know, perhaps the gender, just as a filter here. So this is not a modern data set because I only have female and male, but I can filter it, and the report will be filtered for me directly using this. This is an experience like I've had it, like I have built this as an import data model because all the compute power is done by the Kusto query language. But what if I have extreme amount of data, like 88 billion rows? What do I do then? Because you saw if I had 1.1 billion rows, I'm waiting perhaps a second or two to get the results. What if I have extreme amounts of data? Then I have the third option to build a Kusto function. And let me show you that here. This is the Kusto function. A function is just a stored procedure. In this case, I have a Kusto function called getSysLogs. It accepts two parameters, time window, as a string and bucket as a string. I'll get back to those later. And then it connects to the help cluster. And this I need to do because I cannot create a function on the help cluster. So I need to create this function on my own cluster and then query the help cluster. The help cluster is open to everyone, so I can do cross-cluster querying. It's quite fine. The help cluster connects to the database called sample logs, and it connects to a table called raw syslogs. Then a pipe to do, now I'm doing something with this table. I'm starting to filter the timestamp, that's just a column. And then I have a specific Kusto functionality here. A go is giving me the possibility to just forget what today's date is, and just say, give me data where greater than 300 days ago. And 300 days is written in text, so 300D as in days, 1H as in 1 hour, or 1Y as in 1 year. So I don't have to think about what today's date is. I can now input, give me data 300 days ago, 400 days ago, 1,000 days ago, 1 year ago, and so forth and so forth. The next thing, I'm doing a calculation, a very, very simple calculation, just a row count. I'm calling that calculation log count. It is doing a count and is grouped by name. And then another function called bin. If I'm in the time window selecting 30 days, give me data 30 days ago, and the bin is 1 day, then I get grouped data sets in bins of 1 day. So I get 30 groupings, 30 rows by grouping here. If I were to select, give me 1 year ago and give me in buckets of months, of 1 month, then I'm getting 12 buckets. If I select, give me in buckets of 2 months, then I'm getting 6 buckets, and so forth and so forth and so forth. And then an order by, I would never do an order by in a stored procedure because the result set is not dependent on the order by. But in this case, just to show you that the Kusto engine can perform quite effective also by doing order bys, I'm adding this. To call this, I'm calling get syslogs, and then 5 days as my time window is in this example, and the bucket is 1 hour. So in this result set, I would get 5 times 24 buckets out of this. Back to Power BI. There you go. And again, get data. Kusto. There you go. Connect. And now I need to connect to my own cluster, and the cluster is right here, and the function is here, the get syslogs. But there's a problem. Once I've created the get syslogs, I cannot, there is no 3-dot menu as I have in my table here. The table get me 3-dot menu to select data, build Power BI report, delete the table. But I can't do anything with this here. So I need to go into my explore data option, and there's an option here to show function get syslogs. If I execute this, then I'll zoom in in just a few seconds. If I can, there you go. Then you can see this is the name, this is the parameters, and this is the body that I'm now connecting to my cluster with. The function that you just saw in PowerPoint. This is the function. So let me just once again copy the query URI, copy, paste that in the cluster, and select the direct query mode. That's fine. And here I'm selecting the get syslogs. It has a different icon here, an FX icon. It is a function instead of a table. And once I hit it, Power BI instantly sees that this has 2 parameters, a time window, and for this demo, I'll just write in 400 days, and the bucket is 30 days. Apply. Then I get a snapshot of what is this dataset looking like. I have the name, I have the timestamp, and I have a log count. And see these log counts. This is not a small table. I have a huge amount of data here. And let me load it. Move that and move that out of the way. Get syslogs. Just have a log count. No, actually, let me show you something here because you need to know this. Let me add the name. That's quite fine. And the timestamp. Oops, now I'm getting an error. If you don't know this, you need to know this now. Power BI can only handle 30,000 rows in one visual. So here I'm having a Cartesian product between name and timestamp because I don't have any values in it yet. So Power BI has more than 30,000 rows in the dataset, and it cannot handle that. If you ever see this error when dragging and dropping data from your Kusto sources or any other sources for that matter, just add a measure and you will be good to go. If I add a measure now, things will start to happen. Let me change this to a table so we can see that. And let me change the, there we go. So I can show you the bucketing. I'll zoom in, just hang on. There you go. This is the timestamp, and I chose a bucket of 30 days. So this is the first bucket. And then 30 days after that is this one. It is in the different order. Let me just do it once again. There you go. Now it has, I can't zoom now. There you go. This is the first bucket, 22nd of November. And then 30 days later is 22nd in December. And 30 days later is January 21st, and so forth and so forth. I think you get it now that this is the bucket. If I were to choose 15 days, then I would get the next one is not December 22, but December 17th. Now I can't get out again. What is happening? There you go. Sorry. But now I've hard-coded all the values in my query. Perhaps it would be nice to have the end user adding in the parameters for me. But the end user cannot manipulate the Power Query statement, so I need to do other stuff here. Here I need to, I have borrowed the approach from Chris Webb, the good guy here. So I need to do a few steps here. First of all, I need to add two parameters. One parameter is the time window. Whoa. Without caps lock. Time window. It is text, and right now let me put in 400 days. And this parameter is the bucket. It is also text, and right now it was 30 days. Okay. And in the advanced editor, I can now, oops, not this one, sorry, for this one. In the advanced editor, I need to change these two values, not the 400 days and the 30 days, but the parameters. This was the time window. And this is the buckets. Fine. So now I have two parameters, and I can now manipulate the report as a developer quite easy. But I'm still not able as a end user to manipulate these parameters. How do I do that? Well, Chris Webb is here for the help. I need to create two blank queries. One blank query for the time window. And in the advanced editor, I need to type in this special things here. This is perhaps the simplest input I could get in a blank query, because I have a table with one column called time window filter, and that column is text. It is nothing else but an empty table with one column, no rows in it. And let me do the same thing for the bucket. Just need to get the text here in the advanced editor. There you go. Again, the bucket filter is just a column in this table, and the table is empty. There you go. Close and apply. Let this just resolve. There you go. And now in my data model view, I now have a special option because I have a data model with only direct query sources. I have a special option in the advanced option on each column. In this bucket filter, in the bottom of the advanced option, I have an option called bind to parameter. So I can bind this column to a parameter. So let me bind the bucket filter to bucket, and then I'm getting a potential security risk, of course, because now I'm enabling the end user to put in perhaps SQL statements to do drop table or give me all the metadata from this database. But we are in the Kusto world, and the Kusto world is protected out of the box from injection. So you cannot do Kusto injection or SQL injection in Kusto, because everything you toss towards the engine is executed as one statement. You don't have a delimiter or a go option or a semicolon or something. It is executed as one statement. So you're good to go here. Don't worry about it. The time window filter, I will also bind to the query of time, to the parameter of time window. So now I'm ready to add these parameters to my report. And I have it here, the bucket filter on the page, and also the time window on the page. Perhaps it is more in, is it better to add them in the other way around? There you go. So the bucket filter, I'm changing them all to advanced filtering, because then I'm getting the option to write in my own text. So right now I have a bucket of 30 days. Perhaps I would like to have that in 50 days, sorry, 15 days. And the time window filter is perhaps 3 years ago. Apply. That doesn't work. Let me put in 600 days instead. Apply. There you go. So now you can see I can now manipulate the data as I see fit as an end user, and I can now also change the granularity of my report detail level. I haven't seen this option in any other DAX format in any report being done quite easy. I selected 15 days as my bucket, so my first timestamp is December 7, and my next timestamp is now December 22, because that's 15 days later, and so forth and so forth. I could also change this to perhaps 300 days back, and if it has data, it has, and perhaps I would have this in 1 hour buckets. There you go. Now I have a bucket of 1 hour. The first timestamp is August 1st at 12 p.m. and then an hour later it is 1 p.m. Sorry for that. It is 1 p.m. And 2 p.m. and so forth and so forth. I can now manipulate the data as I see fit in any means, in any bucket I see fit. Let me see if I can I get this in 1 second? This will take some time. No, I can't, because now I'm getting more than 30,000 rows. Let me filter this back to perhaps 250 days. No, I can't. That's fine, but I would just, I would have loved to show you that I could also get a result set back in a second bucket. But let me just give this back to 1 hour and add this back to 400 days. Apply filter. There, now I get it, and I can now begin to build a report as I see fit. I know there exists custom visuals that enables you to put in data to a parameter directly in the canvas, if you would like that, but that is not what I'm showing you today. I have 8 minutes left. Perhaps I could just briefly touch upon the data activator so you can see what is actually happening here. In the new, I can select the sample in the data activator. This sample now starts to load. I hope this will load before we end this session. It does. It gives me several triggers here. A trigger is just what do you want to happen when things go haywire. And as I begin, it will begin to load data eventually here, and you will see different temperatures coming in. And here I can see if any value becomes greater than 50, and with perhaps special filterings, do stuff. Send a mail to me, send a Teams message, and as I told you, I cannot yet choose custom action, but once they are enabled, I can also start Power Automate or do something else, call an API or something. This is just a demo set, and you can see now the temperatures are coming in, and if this temperature perhaps were to exceed 25 degrees, if this were to exceed 25 degrees and the filter is, I don't know, it is HFX99 something something, then send me a mail with something, and then you're good to go with Data Activator. And this is just a very, very extremely short demo of how the Data Activator works. This could be an entire session, but now you have seen that there are possibilities to have a demo thing of Data Activator and then start to play around with it. You have different options here, perhaps also the delivery time in Redmond for shipments and package delivery time if they are failed, and so forth and so forth and so forth. And a decent amount of demo things where you can do stuff. And back to the slide deck. This is not working. Sorry for that. Just hang on. Why is this not working? Why is this not working? Oops. Let me swap this one. There you go. Thank you for attending. This was my session. And if you have any questions, please pop them in the chat or just let me know and I'll gladly answer them.